Okay, so today I'll be talking about carbocation stability, as I thought that was something that was a little bit more on the complicated side. So a carbocation is formed when either a sigma bond between a hydrogen and a carbon atom is broken, or in a more likely scenario, when a pi bond between two carbon atoms is broken and the electrons will travel somewhere else. And this will leave the carbon atom with only three bonds and no lone pairs, which makes it have a positive charge. So generally, carbocations have three sigma bonds, like in this methyl carbocation here, and and that's because double bonded carbocations are generally extremely unstable. So because they're positive, carbocations will be stabilized by anything that will donate electrons to them, especially through resonance structures. And they can also be given more stability through steric factors. So as an example, this tertiary carbocation, which is also stable for other reasons, will be harder to attack than this methyl carbocation, which is much smaller, although the modeling kits aren't perfect for that example. And so there are several ways carbocations can be stabilized. The first one is through alkyl groups, because these R groups or alkyl groups are donating. The more alkyl groups a carbon cation has attached to it, the more stable it will be. So as we go from methyl to primary to secondary to tertiary, the carbocation will get increasing stability. And as the textbook notes, the methyl and primary carbocations are usually so unstable that they will not exist. And another factor that stabilizes carbocations is resonance. Because the carbon is sp2 hybridized, it's able to share some electrons with another carbon if it has a double bond. So in this case, a double bond can share its electrons, and it will flip the positive charge between two different carbons, which will increase stability. And the more resonance structures a carbocation has, the more stable it will be. Because instead of being, say, a full charge, like in this tertiary carbocation, it'll become a half charge in this allyl carbocation, and maybe something like 1/4 of a charge in this benzoic carbocation. So here you can see that each one of these pi bonds can move over, and this will greatly stabilize the carbocation.